All right, Mr. Antonucci here. We're wrapping up section 9A. We're going to talk about calculating and interpreting a t-interval for the slope. So this is going to be a confidence interval used to estimate the slope beta of a population regression line. And as with any inference procedure, we're going to follow the four-step process. So here's our example. Cars and trucks lose value the more they're driven. Can we predict if the price of a used Ford F-150 Super Crew 4x4 if we know how many miles it has on the odometer? A random sample of 16 used Ford F-150s was selected from among those listed for sale on autotrader.com. The number of miles driven and price in dollars were recorded for each of the trucks. Here's our data as well as some graphs and computer output from a least squares regression analysis of the data. Okay, so we have our data here. We have a scatter plot. We have a residual plot. We have computer output, and we have a histogram of the residuals. So we want to construct and interpret a 90% confidence interval for the slope of the population regression line. Got to still follow that four-step process. First thing is state what we're going to do. We're going to construct a 90% confidence interval for beta equals the slope of the population regression line relating y equals price to x equals miles driven for Ford F-150 Super Crew 4x4s listed for sale on autotrader.com. Notice how specific that context is, and also notice we're using B or beta rather, and not B. Remember, B is the sample slope, beta is the population slope, and what we're trying to do is create a confidence interval for that, for beta. So our plan is we're going to do a t interval for the slope, and then we got to check the conditions. So remember, in the plan step, before you check the conditions, state the procedure, the process that you're going to check the conditions for. So if we look back at the scatter plot and the residual plot, the scatter plot looks roughly linear, and the residual plot doesn't have any pattern to it. They're roughly scattered about. For the normal condition, there's no strong skewness or outliers in the histogram of the residuals right here. Now, notice it's not, it's not very normal looking, but that's okay. We're not going to worry about small, differences or anything like that. We're just looking for major issues, and there aren't any. So the variability of the points around the residual equals zero line appear to be about the same at all x values. So you have pretty much equal standard deviations. Then the random, we said it was a random sample of 16 used Ford F-150 Super Crew 4x4s on autotrader.com. And it's reasonable to assume that that's less than 10% of all of them on the site. In the do step, we're going to calculate the degrees of freedom. 16 minus 2, that should be 14 there, not 15. The t-star critical value is 1.761. We got that from the calculator doing inverse t, but you could also use table B. And so from the computer output, we have miles driven. The coefficient or the value of that is negative 0.16292. And the standard error is 0.03096, which we got here. That's the number under the coefficient. Okay. Multiply that by our t-star critical value, plus or minus it from the sample slope, and we get our confidence interval. So now we're going to write our conclusion. We are 90% confident that the interval from negative 0.21744 to negative 0.10840 captures the slope of the population regression line relating y equals price to x equals miles driven for used Ford F-150 Super Crew 4x4s listed for sale on autotrader.com. In other words, we're 90% confident that the average price of a used Ford decreases by about 11 to 22 cents per mile driven. Okay, so when you see lists of data values on an exam question, don't just start putting the data into your calculator. You might be tempted to do that. But like with this question, we didn't have to put all that data into the calculator. So make sure you read the question thoroughly first. Oftentimes, information is going to be provided that makes it unnecessary to enter all that data into your calculator, thereby saving you valuable time on the AP Stats exam because it is a timed exam. So, with that being said, up to this point, we've used computer regression output for inference about the slope of population regression line. Now, the TI-84 and some other calculators, but we're going to look at the TI-84, can perform these calculations when you have the sample data. So if we take that same data that we had from the Ford F-150, if we hadn't had the computer output, okay, we could enter the X values into L1 and the Y values into L2 in our list. And then we hit the stats button, arrow over to tests, and then scroll all the way down. It's going to be down pretty far, buried in there. Lin reg t int. Okay, that's linear regression t interval. In that, we're going to list the X list is L1, the Y list is L2. We always keep frequency as 1. Confidence level, change that to whatever it is. In our example, it was 0.9 or 90%. And then we can hit highlight calculate and hit enter. The 90% confidence interval is going to be reported along with the sample slope, degrees of freedom, standard deviation of the residuals, y-intercept, r squared, and correlation. So the value of S is the standard deviation of the residuals, not the standard error of the slope. So just be careful there that you understand what all these different variables here represent, or letters rather. All right, guys, that's it. We've wrapped up this section. Hope that was helpful to you. As always, reach out if you have any questions, and take care.